Hello everyone, Professor Adjman here with another linear series episode. This is episode 12 and we're going to talk about point slope form. So with point slope form you have to be able to get a slope and a point to write the equation of a line. That's why it's called point slope form. So we're going to do three examples in this video. Those examples are on your screen now. So if whatever you're working on currently looks like these problems, then this is the correct video for you. So let's go ahead and jump into it. So first of all, we have the general form, the general equation for this point slope form, and it's read as y minus y1 equals m times x minus x1. And it's key that this x minus x1 is in parentheses. All right, so the m is the slope, and the point that we're going to use is x1, y1. Right, so these are the two pieces that we need in order to plug them into this equation and get an equation of a line. Alright, so I think this will be a lot easier to see with an example. So let's look at our first example, where we have the point 31 and a slope of 2. Alright, so this point can be written in the form of x1, y1, meaning 3 is x1 and 1 is y1. And then we're also told that m, our slope, is 2. So if we look at the equation of y minus y1 equals m times x minus x1, all that we have to do is plug in these values. Right? Y minus y1, we've identified our y1 to be 1. So I'm going to plug that in parentheses. And this is key because if we have a negative here, we want to make sure that we're doing minus a negative and turning it into positive. Okay, but in this case it's positive, so we have y minus 1 is equal to m, our slope is given to us, it's 2, times, again in parentheses, x minus 3 is our x1. So from here, all that we're going to do is change any signs that we need to change, right? So this is y minus 1, so rather than put it as y minus 1 in parentheses, we can have it as y minus 1 is equal to 2 times x minus, again, this is just positive 3, so x minus 3. You might be tempted to distribute this 2 and move the 1 over to write y equals, but that would be writing it in slope-intercept form, which we talked about 2 episodes ago, and we graphed it last episode. But we want the equation written in point-slope form, so while it looks strange, this is actually what we're looking for. But what happens if we're not given the slope? We're given 2 points. Well, fortunately, we have an equation for slope that we've looked at and used multiple times now of the difference in y's divided by the differences in x. So we can take our second y value 6 and subtract the first y value 4 divided by the second x value 3 minus the first x value 2. So 6 minus 4 is 2, 3 minus 2 is 1, 2 divided by 1 is 2. Right, our slope is 2. So if we look at the general form of point slope form, y minus y1 is equal to m times x minus x1, we have our m. Let's plug that in. So now I need a point, but I'm given 2 points in the problem. Now here's the great thing about point slope form is that it doesn't matter which point we use. I can use this first point of 2, 4 and plug those in. Or I can use the second point 3, 6 and plug those in. And if we kind of rewrite this to get rid of these parentheses that we don't want, just like we did in the last one, we have y minus 4 is equal to 2 times x minus 2. Or we could have y minus 6 is equal to 2 times x minus 3. Either of these answers would be the equation of a point slope form line that goes through these 2 points. I know they look different, but in the next video we'll be graphing these equations, and we'll see that when we graph them, they are the same exact line. Okay, so to recap, it does not matter which point we pick to plug in to the point slope form equation. Let's look at one final example. Again, we're not given the slope, so we need to find it, right, by taking the difference in y's divided by the differences in x's. So our second y is negative 8, and our first y is negative 5. Our second x is 1, and our first x is 3. Negative 8 minus negative 5 becomes negative 8 plus 5. 1 minus 3 is negative 2. And negative 8 plus 5 is negative 3 divided by negative 2, which is going to give us positive 3 halves. Okay, so this positive 3 halves is our slope. Let's go ahead and write that in the equation. Y minus y1 is equal to m times x minus x1. Plugging in the slope, we have y minus y1 equals 3 halves times x minus x1. And again, we can pick either one of these points we want. So let's write it both ways to be complete. But when you do this, you only need to do it one way. Right? Pick whichever point you want. So we can have y minus, if we let this first point be y1 and x1, y minus negative 5 in parentheses equals 3 halves times x minus 3 in parentheses. Or if we use the second point, we can have y minus negative 8 in parentheses is equal to 3 halves x minus 1 in parentheses. If we simplify to get rid of these parentheses, we do have a minus a negative here, so this becomes y plus 5, being equal to 3 halves x minus 3. And over here we have y minus negative 8, which becomes y plus 8 is equal to 3 halves x minus 1. Again, these are going to give us the same line. Both of these lines, although they look different, are point slope form equations that go through the 2 given points. So either of these would be acceptable answers. If you found this video helpful, consider giving it a like and consider subscribing to the channel. Thanks for watching, good luck, and we'll see you in the next one.